Good afternoon, everyone. So welcome to my YouTube channel, Math Sutram. So today we are going to see fifth problem set on functions of bounded variation. Till now, if you have not subscribed my YouTube channel for such type of interesting questions, subscribe it immediately. So today's session is going to be very interesting. It contains 10 questions. Okay. So let's start today's session now. So let alpha, beta are real numbers. Alpha is greater than beta and beta is greater than 0. It means alpha, beta are positive numbers and alpha is greater than beta. Consider the function fx is equal to x to the power alpha upon alpha minus beta cos pi upon x to the power beta upon alpha minus beta if x belongs to 0, 1, close interval. And it is 0 if x is 0. Option number 1 is f is differentiable and its derivative is bounded. B, f is differentiable and B is f is limited function. C, f is function of bounded variation. All of the above. So let's check it. First, we have to check derivative at 0. Okay. Derivative at 0. Okay. So, what is that? Suppose it's derivative at 0. Okay. So, what is that? Limit x tends to 0 plus x to the power alpha upon alpha minus beta cos pi upon x to the power beta upon alpha minus beta it is. Okay. Pi upon x to the power beta upon alpha minus beta. Okay. Minus 0 upon x minus 0. So what you will get? Limit x tends to 0 plus, I'm taking limit at 0 from right. So it is x to the power 1 power will be minus, it will be x to the power beta upon alpha minus beta cos pi upon x to the power beta upon alpha minus beta. Cos functions are bounded and this is positive power. So this is going to be 0. It means f dash at 0, that is exist. Okay. Now, what about if x is not 0? Then what will happen? If x is not 0, then what will happen actually? If x non-zero, okay, then what will happen? So f is actually x to the power alpha upon alpha minus beta cos pi upon x to the power beta upon alpha minus beta. So take differentiation, f dash is equal to, if I will take differentiation, it will be alpha minus beta x to the power beta upon alpha minus beta cos pi upon x to the power beta upon alpha minus beta. Okay. Now take differentiation of this. This will be to the power alpha minus beta sin pi upon x to the power beta upon alpha minus beta. Okay. And this is minus minus beta upon alpha minus beta, and in it will be x to the power positive. It will be add 1 will be add, so it will be alpha upon alpha minus beta. Okay, so this is cancel out. Okay, so this is cancel out. So what is this? Alpha upon alpha minus beta, x to the power beta upon alpha minus beta, cos pi upon x to the power beta alpha minus beta, and this is what? Beta upon alpha minus beta sine pi upon x to the power beta alpha minus beta. This also adjust. Okay, adjust. So it means f dash adjust on 0 1. So this implies f is differentiable. Okay, now f dash at 0 is 0, and f dash x is nothing but alpha upon alpha minus beta to the, okay, it is this is f dash x is alpha upon alpha minus beta x to the power beta upon alpha minus beta cos pi upon to the power beta by alpha minus beta plus beta upon alpha minus beta sine pi upon x to the power beta alpha minus beta. Okay, so what is the derivative here? It means f dash x, because I am taking x belongs to closed interval 0 1, open interval 0, so x cannot exceed 1, and cos and sine function cannot exceed, their absolute value cannot exceed 1, so it will be less than alpha upon alpha minus beta into 1 plus beta upon alpha minus beta into 1. So what is this? Alpha upon alpha minus beta plus beta upon alpha minus beta. So this implies f dash s is less than alpha plus beta upon alpha minus beta for all x belongs to closed interval 0 1. Because at derivative at 0 it is 0. So it means derivative is bounded. F dash is bounded. So it means f dash exists and bounded on 0 1. On 0 1. And we know if derivative exists. Okay, if derivative exists and bounded, then this implies f is Lipschitz function. Okay, if a function is Lipschitz on a closed interval, then it is function of bounded variation. Every Lipschitz function is function of bounded variation. So this implies f is function of bounded variation. So which options are correct? All options are correct, because question is f is differentiable and derivative exists, derivative is bounded, that is correct. F is Lipschitz, because if function is differentiable and its derivative is bounded, then it is Lipschitz. And we know every Lipschitz function is a function of bounded variation. So all first three options are correct. This means option number D is correct. All of the above. Okay. So this question is done. Now move to second question. So the second question is same. Only cos is replaced by sin. You can use same technique. Okay, you can use same technique I have used in question number 1, and you will find f is differentiable and its derivative is bounded. First option is also correct. Second option is correct because every function which is differentiable and derivative is bounded going to be lifted function. And lifted function is function of bounded variation. So this is option number D is correct, all of the above. Okay, same technique you use as I have used question number 1. So same solution will be followed. Okay, only you replace cos by sin. Okay, so which option is correct? Option number D is correct. Now see this question. Fx is equal to x to the power alpha cos pi upon x to the power beta. X belongs to open 0 1 close, and it is 0 if x is 0, such that beta is greater than 0, then f is function of bounded variation on 0 1 if and only alpha is less than beta, still less than beta. Okay, so this is option number A, B, C, D. Okay, alpha is strictly less than beta. Second option is alpha is greater than beta. Third option is alpha is equal to beta. None of the above. Okay, none of the above. So which option is correct? Let's check it. Suppose I am taking alpha greater than beta, but beta is already greater than 0, so this is going to be okay. So I am taking this case, and I am considering this function gx is equal to x to the power alpha upon alpha minus beta cos pi upon x to the power beta upon alpha minus beta if x belongs to open 0 1 close, and it is 0 if x is 0. Okay, by question first, G is Lipschitz function, because the question is same. Gx is same as given f in question number 1. So G is Lipschitz function. If this is a Lipschitz function, we have Gx minus Gy less than, we have there exists k greater than 0, such that k times x minus y. Okay. Okay. So let's say equation number 1. Now let P n is equal to ax naught, x1, x2, xn is equal to b. A0 here. B partition of close interval 0 1. Now you check that, observe that f x to the power alpha minus beta is nothing but, sorry, f g observe that g x to the power alpha minus beta is nothing but fx. Okay. Now SPF. SPF. What is SPS? SPF is going to be summation I goes to 1 to n fxn minus fxn minus 1. So by this, what I will get here? Summation I goes to 1 to n g xn to the power alpha minus beta minus g xn minus 1 to the power alpha minus beta. Okay. But g is a Lipschitz function by equation 1. By 1. What we have, this is less than I goes to 1 to n xn to the power alpha minus beta xn minus 1. Sorry, this is not xn. Actually, this is I and I minus 1. Okay. xi minus 1 xi minus 1. So this is xi to the power alpha minus k times, because g is Lipschitz function by equation 1, we have xi minus 1 to the power alpha minus beta. Okay. But xi is greater than xi minus 1. So what we, and alpha minus beta is greater than 0. So this is what summation I goes to 1 to n xi to the power alpha minus beta minus xi minus 1 to the power alpha minus beta. Okay. So after solving it, what you will get? After solving it, what you will get? You will get, what will be get? You will get a, and this will be x n minus xn to the power alpha minus beta x naught to the power alpha minus beta. Okay. But xn is 1. This is, and x naught is 0. So what you got? A 1 minus 0. So this implies SPF is less than equal to K. Okay. It means supremum P belongs to SPF is less than. So this implies supremum P belongs to row 0, 1. SPF exists in R. So this implies F is function of bounded variation. If alpha is greater than beta. Okay. we have proved that f is function of bounded variation if alpha is greater than beta. What about the case if alpha is less than beta? To take this partition, Pn is equal to 0, 1 upon n to the power 1 upon beta, then 1 upon n to the power minus 1 by 2, 1 upon beta, then 1 upon n minus 1 to the power 1 upon beta, then 1 upon n minus 3 by 2 to the power 1 by beta, and so on, then 1 by 2, then 1 upon 2 minus 1 by 2 to the power 1 by beta, and last point is 1. For all n greater than equal to 2, then you will find Bf is greater than, because Bf is always greater than this, and SP and F, what is this? This is 1 plus summation I goes to 1 to n, 2. This is 1 upon I to the power alpha upon beta. Okay, alpha upon beta. And we know that if alpha upon beta is less than equal to 1, so this series is divergent. So this will tend to infinity as n tending to infinity. So this means Bf is infinity. It means f is not function of bounded variation if alpha is less than beta. Okay. So now check which options are correct. If alpha is less than beta, it is going to be not function of bounded variation. And if alpha is greater than beta, it is function of bounded variation. If alpha is equal to beta, it is not going to be function of bounded variation. None of the above. So which option is correct? This option is correct. D option is correct. Okay. So now move to next question. Fx is equal to, this question is same as question number 3, only cos is replaced by sine. Okay. You can use same technique. Okay. Same partition. You will find that which option will be correct? Option number 7 will be correct. You use same technique as we have used in question number 3. Only cos is replaced by sine. Okay. Now move to fifth question. Okay. Now this question is given. Fx is equal to x cos pi upon x if x belongs to open 0, 1 close, and 0 if x is equal to 0. F is differentiable. This is not differentiable because it is not function. This function is not differentiable at x is equal to 0. Okay, you can check. Limit f is to 0 plus x cos x 1 pi upon x minus 0 upon x minus 0. This will be limit x tends to 0 plus cos pi upon x. So limit does not exist. Not exist. Okay. So this implies f is not differentiable at 0. So it is not differentiable. Okay. But this function is continuous. This is not differentiable. So option number A is not correct. F is not continuous. F is continuous. You can check F is continuous actually. See, F is not function of bounded variation. F is function of bounded variation. So you use by question number 3. Use question 3. Now we have this one. You see that fx is equal to, it is given that it is x cos pi upon x if x belongs to open 0, 1 close and 0 if x is equal to 0. What is alpha here? Alpha is 1. X to the power alpha is 1. And what is beta? Beta is 1. So it means alpha is equal to beta. Okay. By question 3, we have f is not function of bounded variation. By question number 3, f is not function of bounded variation because alpha is 1 and beta is 1 and alpha is equal to beta. When alpha is greater than beta, then function is function of bounded variation. But here alpha is equal to beta, it means f is not function of bounded variation. So option number C is correct. F is not function of bounded variation. Okay. Now question number 6, move to. Okay. Now you can check this function is differentiable. This function is differentiable. Okay. Why? Because it is differentiable at 0. Because limit x tends to 0 plus x square cos pi upon x square upon x minus 0. What is this? Limit x tends to 0 plus x cos pi upon x square. Cos function is bounded, so this is going to be 0. So f is differentiable at 0. But you can check if x is not 0, it will be differentiable. So it is differentiable on closed interval 0, 1. So option number A is not correct. You can check f is continuous. Okay, so option number B is not correct. F is not function of bounded variation. D option is f is function of bounded variation. Now again you use question number 3. What is so function f given? F is given f(x) is x square cos pi upon x square. Okay. If x belongs to open 0, 1 close and 0 if x is 0. So what is alpha here? Alpha is 2. Beta is also 2. And alpha is equal to beta. By question 3, f is not function of bounded variation. Okay. So which option is correct? F is not function of bounded variation. Okay. So again, you can check that f is not differentiable function. Question number 7. You can check f is not function. F is not differentiable function. You can check because f is not differentiable at 0. Okay. Now f you can check f is continuous. So option number B is not correct. Now what is C option is f is not function of bounded variation. D option is f is function of bounded variation. Now see that what is alpha here. Alpha is equal to alpha is equal to 1 by 2 and beta is equal to 1. So alpha is less than beta. So by question 3, f is not function of bounded variation. Okay. So f is not function of bounded variation. Which option is correct? Option number C is correct. Now, question number 8, you see, next question. This question is 1. Now, this function is not differentiable. You can check as we have done. This question is similar. This question is similar like fifth question. Okay. Fifth question. Only cos is replaced by sine. F is not differentiable. Okay. You can check it. F is continuous. You can check it. It is easy to check. Now, C option is F is not function of bounded variation. D option is F is function of bounded variation. So now you see that we will use question number 5 here. Question number 4 we will use here. You first see what is F. F is given x sine pi upon x. If x belongs to open 0, 1 close and 0 if x is 0. Now what is alpha here? Alpha is 1, beta is 1. Alpha is equal to beta. By question 4, f is not function of bounded variation. So which option is correct? Option number C is correct. We have done all such question already, but we are using short trick to find the solution. Now we are solving this question by short trick. Okay. If alpha is less than equal to beta, then function is not a function of bounded variation. If alpha is greater than beta, it is function of bounded variation. That technique we are using here. In cos and sine, both these such functions. Okay. By question 3 and 4. So in this, option number C is correct. Now move to next question. Now this question is similar to question number 6. Only cos is replaced by sine. Okay. So f is not differentiable. F is differentiable. F is continuous also. So option number A and B are not correct. F is not function of bounded variation. D option is F is function of bounded variation. Okay. So let's see it. So now you see that what is alpha here? Alpha is 2 and beta is also 2. So alpha is equal to beta. By question 4, F is not function of bounded variation. So which option is correct? Option number C is correct. Okay. I am repeating this question. Why? Because I am using short technique to solve this question. Okay. Because by technique it is simple to evaluate this question in only half second. Okay. Or maybe 10 or 15 seconds. So F is function of bounded variation. Sorry, F is not function of bounded variation. So option number C is correct. Now move to last question. This question is similar to question number 7. Only cos is replaced by sine. So this function is not differentiable. This is continuous. So option A or B are not correct. C is F is not function of bounded variation. D is F is function of bounded variation. So let's check it. So what is alpha here? So alpha is 1 by 2 and beta is 1. So alpha is strictly less than beta because 1 is less than 1. So by question 4, f is not function of bounded variation. So which option is correct? Option number C is correct. So option number C is correct. Okay. So today's session up to this. In this we have find a technique when such function x to the power alpha cos pi upon x to the power beta and fx is equal to x to the power alpha sin pi upon x to the power beta, when these functions are functions of bounded variation. If alpha is less than equal to beta, these functions are not function of bounded variation. These functions are bounded variation if and only if alpha is strictly greater than beta, where beta is greater than 0. Okay. So today's session up to this. Like, share, comment and subscribe my YouTube channel. So thank you very much for today's session. Thank you very much. We will see you in next session.